So this is an addition to the previous video. So this is still on lesson 4.1, the systems of linear inequalities. I want to go over a slightly longer example in which you have more than two constraints. It's true that most problems, not most, but many problems have only two constraints, but I want to point out that there is no restriction on the number of inequalities that you have in the system. So you could have 3 or more inequalities. The idea is the same. What I want you to do when you go over this video is maybe try to pause and work ahead of me and then check to see if you got it right. And also at this point, try to visualize the region which constitutes the solution of the system of inequalities without actually drawing that pattern of lines, because the more constraints you have in the system, the messier it gets, essentially, if you draw those lines to mark the region for each constraint. So just visualize it, or better yet, write down in words a quick description of whether you are on one side of the line or the other side of the line. Typically, it's enough to say the region below the line or above the line. So below or above the line, or left or right of the line is the solution of each constraint. Below or above, right, left or right, I mean, that depends on the inclination of that line. It's up to you, basically, once you sketch the line, to decide which way it goes. But either way, whatever you do, try not to actually paint, in other words, draw those pattern lines, to that fill in the region, basically, because if you do that for each constraint, like I said, it's kind of messy. We did that in the beginning just to illustrate the concept, but later on try to avoid that. Okay, so with that being said, let's start with the example. So let's say you have 3 constraints given by 3 linear inequalities. Let's say we have minus 2x plus y less than or equal to 1, 2x plus y less than or equal to 5, minus x plus 2y greater than or equal to 0, and as it is often the case in real life applications, x and y are positive quantities because they usually represent some physical quantities in these problems. So we follow the same recipe like before. We start by sketching the lines corresponding to each of these inequalities. Again, this is sometimes a little bit confusing because we abandon the less than or greater than sign and we replace them with equalities. But this is simply because we want to sketch the border between one inequality and the opposite of it. And then we're going to choose the correct one depending on what we have in the actual system. So we're going to define these lines corresponding to each inequality. So line 1 will be minus 2x plus y equals 1. Line 2 will be 2x plus y equals 5. Line 3 would be minus x plus 2y equals 0. And the last two constraints, x greater than 0, y greater than 0, we'll just keep that in mind when the time comes to sketch and visualize the solution of the system. We're going to look at the first quadrant only because that's the one corresponding to x positive and y positive. So let's sketch all of these lines. We're going to have some test points for each of these lines. So let's say, let's start with here with L1. So minus 2x plus y equals 1. And let's try to do this in our minds. If not, you can write it down on a scratch paper. Remember, you need only 2 points to sketch each line. So that means you can plug in any value 1 for x and solve for y. And as usual, as is often the case, the easiest thing to plug in is 0. So if x is 0, y is 1. So that gives you 1 point on the line. And if I plug in 0 for y, obviously x will be minus 1/2. Right? It's easy to do this just by looking at the line, right? Just replace y with 0. So x is minus 1/2. So we have 2 points already, 0, 1, and minus 1 half and 0. So let me do this picture over here on the left side of the page. Let's draw the coordinate system. Oops. That's x and this is y. And let's label the points 0, 1. So x is 0, y is 1. Let's say this is 1 over here. And the point minus 1 half 0. That's going to be over here. So that's x minus 1 half. And y is 0. So that's the other point. And let's draw the line that connects these 2 points. All right, so that's going to be L1. And let's label it as well. Same thing for L2. I'm going to have to get back to this. Well, actually, before we move on to L2, let's actually deal with the inequality as well. So remember, this line separates the two regions in which minus 2x plus y is either greater than 1 or less than 1. Now, in our constraint, we have less than 1. So just pick one point in one of the regions, on one of the sides of the lines, and test that region to see if it satisfies the inequality. Remember, whenever 0, 0, whenever the origin belongs to one of these sides of the line, that's the easiest test point to pick for the inequality, because it's just easy to compute. So I'm going to plug in 0, 0 into the inequality, minus 2 times 0 plus 0, and I'm going to ask myself, does it satisfy the inequality or not? Is minus 2 times 0 plus 0 less than 1? Yes, it satisfies the inequality. So therefore, the region that contains, the test point, that in this case 0, 0, is the solution of that inequality. So in that case, it means the region below the line. So again, refrain from painting or drawing those lines, patterns to mark the region below the line. Just write down that you're going to look at the region below L1, right? The one containing 0, 0. So we're going to do the same thing for each line. Okay, so let's move on to the second line, which is 2x plus y equals 5. Once again, we can plug in x0, and then that means y is 5. And let's be a little bit more creative here, because if I plug in 0 for y, x will be 5 over 2. Let's plug in a nicer number. Let's say y equals 1, because if I do that, then x will be a whole number, right? 2x equals 5 minus 1, which is 4, and then x equals 2. Nothing wrong with 0, but then you will have to plot 5 over 2. So in general, I like to avoid fractions if possible. So 2 points that I found. Again, remember, there can be any 2 points to sketch the line, right? I mean, once you find 2 points on the line, then you can sketch the line. So 1 point is 0, 5. Now, obviously here, 5 is much higher up here, but we're going to exaggerate a little bit by omission, so to speak. So let's say this is 5. This is the point 0, 5. And the point 2, 1 should be further to the right, further to the right over here. So x equals 2 and y equals 1. So that's the other point that belongs to line number 2. And let's sketch it. So that's L2. And let's see, do we look at the region below or above the line? Again, 0, 0 belongs to one of these regions. So 0, 0, it's again a very suitable test point to check the inequality. Again, you look now at the actual inequality that you started with, 2x plus y less than 5. So we plug in 0, 0. Really plug in and verify, because sometimes you may pick the wrong region, and in that case you have to move on to the other side. And in fact, on the third line, I'm going to purposely pick the wrong region just to illustrate how that works. So in this case, 0, 0 is indeed on the region that is the solution of this inequality. 2 times 0 plus 0 is 0 less than 5. That is true. So therefore, the region below the line number 2 is the region that is the solution of this inequality. So you kind of already see that you are under this little house, so to speak, right? So below L1, below L2. So try to visualize that region without sketching anything extra on the picture. All right, so moving on with the third line, minus x plus 2y equals 0. To sketch it, we need 1 point. One of them is obviously 0, 0. If x is 0, y is 0. To get another point, let's say I plug in x equals, let's say x equals, I don't know, actually in this case 2, 1, it happens to be one of the, 2, 1 actually is also a point on this line. But let's say you picked a different one, just to illustrate that you don't necessarily have to end up with the same point. So let's say x equals 1, that means y is 1/2. So minus 1 plus 2y equals 0, y equals 1/2. So one other point will be 1 and 1/2. So you connect 0, 0 with 1 and 1/2, which is over here. That's 1/2, 1 and 1/2, let's say. And then this is the line. Again, it happens to actually go through the point 2, 1. That's just a coincidence. You don't have to actually guess that from the beginning, okay? And it doesn't have to be the case. And that's line number 3. All right, so which side of the line number 3 you should consider for this inequality? The inequality, again, look back again to the original problem, is minus x plus 2y greater than 0. So you can't use 0, 0 as a test point because 0, 0 is on the line. And just pick a point on one of the sides. So let's say I'm going to pick the point 1, 0, which is below line number 3. So I'm testing now the region below line number 3 with the point 1, 0. So I plug in 1, 0 into the inequality. And I ask myself, okay, so x is 1, y is 0. Is minus 1 plus 2 times 0 greater than or equal to 0? Well, that means asking, is minus 1 greater than 0? Obviously, no, right? So that's a false statement. So therefore, it's not the region below the line number 3, but it is above line number 3. So all in all, in the positive region of the plane, because don't forget that x is positive, y is positive. All in all, when you combine all of these conditions, you're looking at the region below L1, below L2, and above L3. And if we look carefully, that means we're looking at the region encapsulated by this polygon, right? I mean, that's like how many sides? 4 sides. It's a quadrilateral, right? So you're looking at this region enclosed by these lines in the y-axis. So that is basically the solution of the system. This whole region is going to be the solution of the linear system the solution of the system of linear inequalities that I started with. In the practical applications, this is called sometimes the feasible region, because these are essentially the possibilities for x and y that satisfy your constraints. Later on, when we have optimization problems, we will have an extra condition that we want to maximize or minimize, or an extra expression to be more precise. And as I said before, one of the most important things to keep in mind in optimization problems is to actually find the coordinates of these corners. Because as you will see in the next lesson, one of these corners will be actually the point that gives you the maximum or the minimum of the objective function in these optimization problems that you will solve later. So one natural question you will see all the time is to find the coordinates of these corners. And the number of corners really depends on the shape of these lines and how they intersect with each other. Obviously, we have already, and let's write them here. I'm going to write the answer here underneath. So the corners are obviously 0, 0, and 0, 1. So 2 corners are already provided in the way we sketched these lines. The question is to find the other 2 corners. Actually, one of them is already found, because the intersection between L3 and L2 is 2, 1. But let's say you don't know that yet. That's just a coincidence. You have to solve a system of equations for each of these pairs. So for example, where do L3, or let's say L1 and L2 intersect? So I'm looking at this corner now. You just basically solve a system between the equation of L1 and L2. So L1, the equation of L1 is minus 2x plus y equals 1. And the equation for L2 is 2x plus y equals 5. Always use elimination, remember, that's the golden standard for this class. When I add the 2, this is 0, 2y equals 6. That's the easiest way to eliminate x. That gives me y equals 3. And if I plug it back into the first equation, let's say minus 2x plus 3 equals 1. That gives me minus 2x equals 1 minus 3, which is minus 2. Finally, x equals 1. Okay, so one corner is 1, 3. This is the coordinates of that corner. These are the coordinates. And then I have to solve another system between L2 and L3. And L2 equation is going to be 2x plus y equals 5. L3 is minus x plus 2y equals 0. Here, let's say I want to eliminate x again. That means I need to multiply the second equation by 2. So that's minus 2x plus 4y equals 0. Add the 2 equations. That gives me 5y equals 5, which means y equals 1. Let's plug it back into the second equation, for example. Minus x plus 2 times y equals 1 equals 0. Minus x equals minus 2, that means x equals 2. So the second corner, or the other remaining corner to find is 2, 1. Always find these corners. I mean, the problems in the homework will ask you to do that anyway, because like I said, when you solve optimization problems, you will need to, I mean, the optimum solution happens at one of these corners as I will explain in the next lesson. So make sure you understand this example and go slowly, and then go over the homework problems. Don't rush. Remember, I really feel strong on this concept of taking as much time as needed. There's no shortcuts essentially. I mean, if you really want to learn a math concept, you simply have to take the time it needs. And some things take less time, some other takes more time. But there are no shortcuts really. If you just basically skim through, you won't learn anything. I mean, you may be able to remember visually some ways to do the problem by plugging in numbers, and you may get lucky, kind of like essentially throwing dice at the casino game or something. But you won't really learn. So time is of the essence, and going through all the work necessary without rushing it. Speed actually comes in mathematics naturally. I mean, once you practice enough, you will find yourself, even without trying, that you can go actually faster on some things, but that should come naturally. So anyway, that was kind of like a philosophy digression, but still keep that in mind. I'll see you next time.